Hello everyone. Welcome to the solution of LeetCode problem 2359 named find closest node to given two nodes. In this problem, you are given a directed graph of n nodes numbered from 0 to n minus 1. Here, each node has at most one outgoing edge. Now, the graph is represented with a given zero-indexed array named edges of size n, indicating that there is a directed edge from node I to node edge of I. And if there is no outgoing edges from I, then edges I is equal to minus 1. You are given two integers, node 1 and node 2. Now we have to return the index of the node that can be reached from both of the node 1 and node 2 such that the maximum difference or the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. And if there are multiple answers, you have to return the node with the smallest index. And if no possible answer exists, simply return minus 1. Now, this is interesting point. Note that the edges may contain cycle. Now here, in the first example, 1 is connected to 2 and 0 is connected to 2, 2 is connected to 3. Now, our starting two nodes are 0 and 1. That means 0 and 1. So here, from 0 and 1, we can reach to the node 2 with the distance of 1 unit. And here, as both of the distance is 1 unit, so the maximum of them will be 1. So 2 is our desired output. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the same example. We can start traveling from the node 0 and from the node 1. Now, from the node 1, by traveling 1 unit of distance, we can reach to the node 2. Similarly, from the node 0, by traveling 1 unit of distance, we can reach node 1. Sorry, node 2. Now here, the maximum of them will be 1. So the node we can reach from both of the starting point is 2 with the maximum distance. So here, how can we solve this problem? We can simply solve this problem by using the BFS algorithm. So how basically the BFS works? We have to use two of the BFS. At the first BFS is start from the node 1, and from 1 we can go its second level, which is node 2, with the distance of 1, and from the node 2 we can go its third level, node 3, with the distance of 2. Now, in the second DFS, from the node 0, it is our starting point, and we can reach node 0 by the cost of 0. Then we can reach node 2 with the distance of 1. Then from the node 2, we can reach node 3 with the distance of 2. So here, in both of the algorithm, we have seen that the intersection point is 2, so we have to return it. Now the question is, how can we solve this problem? We can take two of the array. Each of them has 4 of the cells. Now let's start the first BFS. Let's start the BFS start from this node 0. And so here, the distance of the node 0 will be 0. Now from 0, we will get back to the node 1, sorry, node 2. So the distance will be distance of 0 plus 1, which is 1. Now, from 2, we can reach to the node 3. So here the distance of 3 will be the distance of 2 plus 1, which is 1 plus 1, that means 2. Now here we have completed the DFS and it will be minus 1. Because from the node 0, the node 1 is not reachable. Now, let's start the DFS from the second node 1. So from 1, we can reach to 2. So the distance of 1 will be 0 and the distance of 2 will be 0 plus 1, which is 1. Now from 2, we can reach to the 3. So the distance of 3 will be distance of 1 plus 1, which is 2. And it will be minus 1. Now we have completed the DFS and calculated the distance of each of the node from the starting node in 2 of the arrays. Now we will scan through from left to right of both of the array, and if all of the content in the corresponding index does not have minus 1. So here, this minus 1 basically represents that in the first starting node, we cannot reach the index number 1 or the node 1. This minus 1 represents that from the second BFS, we cannot go to the index number 0. So here, we cannot consider these two pairs because one is reachable and another is not. So we have to consider in the third one, the node which has the index number 2. Now here, this index number 2 is reachable from both of the starting point because it has the distance of 1. So here, as the minimum of both of the distance will be 1, so we have to return the index number 2, which is our desired node that can be reached from both of the starting point. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named edge, which is the connections, and 2 of the starting point, node 1 and node 2. Now, we are declaring a distance 1 and distance 2 array with all of them equal to minus 1. Now, we are taking a queue and inserting the first node and initializing the distance of the first array will be 0 of this starting point. Now, this is the BFS function. We are continuing this until the queue is not empty, and we are taking the front element and removing it from the queue. Now, if the edges of u not equal to minus 1, that means it has a children. So here, if the distance 1 of edge of u is equal to minus 1, this condition is important because if in any number of time this array is initialized for a node, that means it will no longer be minus 1. So here, by checking this condition, the code will never go into a cycle. So here, if this condition is true, then the distance 1 of edges of u will be distance of u plus 1. Now, we have to insert the edges of u into the queue. Now, after completing in the first BFS, the queue will become empty. Again, we will insert the second node and run the BFS for the second node, which is exactly similar. Now, we are initializing 2 of the variable minimum distance and node One will be integer max, another will be -1. Now we have to run a loop from 0 to the size of the edges, and if the distance 1 and distance 2 array does not equal to -1, we have to calculate the maximum, which will be maximum of distance 1 and distance 2 array. And if the maximum distance is less than minimum distance, we have to initialize minimum distance with maximum distance, and node will be I. After that, we have to return the node. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.